In this video I am going to solve exercise 5.3. In this exercise we have only 3 questions. First question, explain why the converse of the theorem. In the exam they will not ask you like the converse of the theorem and all. This is the statement: the perpendicular from the center of a circle to a chord bisects the chord. Solution I am giving. In a circle, the perpendicular from the center, a circle with center at O, a chord say AB, and perpendicular from the chord center. From the center you are drawing a perpendicular to the chord, and you are asked to prove this line segment OD bisects AB. To prove, first step you can write given in a circle with center at O, AB is a chord. You can write like this: in a circle with center at O, AB is a chord and OD perpendicular AB. And what you are asked to prove? To prove OD bisects AB. To prove OD bisects AB, that is, you have to prove AD equal to DB. Now proof. You can join OA and OB. Join AO and BO. Now see, we will take these two triangles. In triangle AOD and triangle BOD, what do we have? You see, this angle equal to this angle. Angle ADO is equal to angle BDO, because each is 90 degree. It is given each is 90 degree. So this angle and this angle are equal, and then AO equal to BO. AO equal to BO, because they are the radius of same circle. Will plural we write radii of same circle. Then OD equal to OD. OD equal to OD, common side for both the triangle. Common side. OD is common to this triangle and it is also common to this triangle. So what we are getting here? See, we are getting here right angle equal to right angle and hypotenuse. This is right angle. This is hypotenuse of the two triangles, and OD equal to AD. So you can write by RHS, right angle hypotenuse side. The two triangles are congruent. Triangle ADO is congruent. This is the symbol. Triangle BDO. So the two triangles are congruent. The corresponding sides by CPCT must be equal. This implies AD is equal to DB. AD equal to DB. And AD equal to DB, this implies D is midpoint of AB. This implies D is midpoint of AB. That is, D bisects AB. And this is the complete proof for this question. Okay. Second question, question number 2, same exercise 5.3, solution. See, an isosceles triangle ABC is inscribed in a circle. It's like this. An isosceles triangle is inscribed in a circle with base BC. So this point is A, center is say O. So given, first step you will write, given ABC is an isosceles triangle, and they said that AD perpendicular BC. AD perpendicular BC. An isosceles triangle ABC is inscribed in a circle with AB equal to, it is given AB is equal to AC, that means this side and this side are equal given. Show that the altitude from A to BC passes through the center O. Altitude is AD is altitude. Altitude means it is perpendicular BC. And what you are asked to prove? To prove AD passes through the center O. To prove AD passes through the center O of the circle. So I think you understood. It is given ABC is a triangle inscribed in a circle. Inscribed in a circle means a circle, the triangle is touching the circle from inside. And then it is given AB is equal to AC, and also it is said that AD is perpendicular BC, and you are asked to prove that this perpendicular AD is passing through the center of the circle. A little bit logical, you have to try to understand. Okay, so at first we will prove that these two triangles are congruent. You see, proof. In triangle ABD and triangle ACD, look, these two triangles we can say they are congruent. See, it is already given this angle 90 degree. Angle ADB is equal to angle ADC. The reason is each is 90 degree. And then it is given AB is equal to AC. It is given this side equal to this side. And then the third side is AD equal to AD. Another AD equal to AD, not the third side. AD equal to AD because it is common side. So we can say, you see, this is hypotenuse. Hypotenuse equal, side equal, and right angle equal to right angle. So we can say by RHS, right angle hypotenuse side, the two triangle ABD must be congruent to triangle ACD. So the two triangles are congruent. If the triangles are congruent, this implies we can say BD is equal to DC, BD equal to DC. That means AD bisects BC. That is you are getting AD bisects BC. And also we know AD is perpendicular BC. It is given. So we have come to the conclusion that AD is bisecting BC and also AD is perpendicular BC. But we know again, you see, we have a theorem, we have proof. Line segment from the center to a chord bisects the chord. Line segment, a perpendicular line segment from center to a chord bisects the chord. We know if OD perpendicular BC, then OD bisects BC. There is a theorem, AD bisects BC. That means OD bisects BC, OD bisects BC, and also OD perpendicular BC. So you see, from the first part, what you got? You see, this is second part. From the first part, you got AD perpendicular BC and AD bisects BC. You got this statement. You got AD perpendicular BC and AD bisects BC. And again you are getting OD perpendicular BC and OD bisects BC. This is the second statement from the theorem. OD perpendicular BC and OD bisects BC. So point O must be on the line of AD, because AD perpendicular BC and bisects BC, OD also perpendicular BC and bisects BC. So AD and OD must be the same line. Therefore OD and AD must coincide. Line segments, you can write like the line segment OD and AD must coincide, must be the same line, must coincide. That is point, we can say AD passes through the center, or that is AD passes through the center O. I am telling you again once. You see, we have proved AD perpendicular BC and AD bisects BC. Bisects BC means this side equal to this side, BD equal to DC. So AD perpendicular BC and bisects BC. Also by theorem OD perpendicular BC and bisects BC. So line AD and OD must coincide. That means the line AD passing through the center of the circle, and this is the complete proof. Okay. See, next question number 3, same exercise 5.3. Question number 3, two parallel chords of length 6 centimeter and 8 centimeter in a circle. Taking a circle with center at O, two chord, one 6 centimeter, another 8 centimeter. So I am taking 6 centimeter, say AB, 8 centimeter bigger, so it will be little closer to center, AB, CD. It is given AB is 6 centimeter, AD is given 8 centimeter, and if the radius of circle is 5 centimeter, so I'll just join this one. This is the radius, it is how much? 5 centimeter. Even this is the radius, it is also 5 centimeter. Find the distance between the midpoint of the chord. Two parallel chords of 6 centimeters opposite sides of. So midpoint, say AB, CD, E is midpoint of AB. You can mention here, E is midpoint of AB. E is midpoint of AB. So if E is midpoint of AB, AB is 6. So AE will be 6 by 2. AE will be 6 by 2. It will be 3 centimeter. So AE I got 3 centimeter. And this distance I don't know, let it be x. It is given perpendicular. Okay, midpoint. Midpoint, we have done a theorem. Line segment joining from center to the midpoint of a chord is perpendicular to the chord. There is a theorem. So you see, in this triangle you can use Pythagoras theorem. By Pythagoras theorem, in triangle, which triangle? AEO. AEO, 5 square plus 5 square. 5 square is equal to 3 square plus x square. Pythagoras theorem. AC square is AB square plus BC square. 5 square is 25. 3 square is 9. Taking the left side negative is equal to x square. If you simplify, you will get x is equal to 4 centimeter. So we got x below. Same way, CD, AB, CD is, mark it F. Again, F is midpoint. F is midpoint of CD. So if it is midpoint, join it. It will be perpendicular because there is a theorem. Line segment joining from center to the midpoint of a chord is perpendicular to the chord. Theorem is there. So CD is given 8 centimeter. F is midpoint, na? So CF will be equal to 8 by 2 is equal to 4 centimeter. So this side is 4. Total is 8. This is middle, midpoint. So it will be 8 by 2 is 4. And this distance, let it be y. And again you can use here by Pythagoras theorem. In triangle OCF, what you will get? You see 5 square is equal to 4 square plus y square. AC square is equal to AB square plus BC square, like that. You simplify, and from here you will get y is equal to 3 centimeter. And you are asked to find the distance between the line segment joining the midpoints. That means you have to find EF. So what will be EF? You can see in the diagram. EF is x plus y, and you got the value of x. How much? X is 4 centimeter here, and y you got 3 centimeter, that is 7 centimeter, and this is the complete proof. Okay.